Good day, good afternoon. This is the continuation of the part 1. So this is part 2 and measurement of horizontal distances. So in this presentation, we talk about the taping correction only. So let's start. So bakit ba tayo a-apply ng mga taping correction? So as you can see in the presentation, we have here an illustration. Pag nagme-measure tayo with the long distances, point A and point B, so nagka-create siya ng sag, lalo na pag yung ating ginagamit is a measuring tape. For example, in the right side, pag old na yung ating tape, medyo nagsishrink or medyo nag-elongate yung ating mga tape, that we need to calibrate or kailangan natin siya i-correct ang mga errors. So in the taping corrections, the operation could either be one of the following. It could be the measure or the layout. So number one, taping to determine the unknown length, that is measurement, or taping for the purpose of laying out a required or specified length. So that is the laying out. So what there's the difference between the laying out and measurement. So meron tayong illustration. If I want to know what is the length of the plyboard, so I'm gonna use the tape to determine its length. So, kung yung ating, for example, yung ginawa nyo sa in your exercise last time, which you measures the, the length of your room or your house. Sa layout naman, you already know the length. So, I need a 1 meter plyboard. So, you're gonna use or you're gonna lay that 5-meter long tape on the plyboard to be cut. So, that's the difference between your measure and your layout. Sa measure, you identify the unknown length. When yung layout, alam nyo yung length ng tape and you apply it to a unknown object. Okay. See how we have different rules in the tape correction. So the first rule, when the line is measured with the tape that is too long, the correction should be added. So we have naman, pag nagle-layout tayo, a length with the tape that is too long, corrections are subtracted. So pag nagme-measure tayo and too short, we must subtract the corrections. And when we lay out, when the tape is too short, the corrections are subtracted. Sige. So, in general, so when measuring with the tape, too long, you add. When too short, subtract. So, do the reverse in the laying out, which means, pag nagle-layout tayo too long, we need to subtract, and too short, we need to add. Again, so, this is the same. When measuring, pag too long ang ating correction, which means positive ang ating nakakome up na correction, we need to add the corrections to the length of the line. Tape is too short, we need to subtract the corrections. When the tape is, when laying out, so the tape is too long, we need to subtract the correction on the measured length. When the tape is too short, we need to add the correction. So we have here the taping corrections. We have here due to the incorrect length, due to temperature, because the temperature outside varies. Pwede yung ating tape is naka-standard lang yung tape into 20 degrees or to 20 to 28 degrees. So pag ginamit natin siya for outside, which is 35 degrees Celsius na, nag-e-elongate yung ating tape because of too much heat. We have naman due to tension or pull, ito yung applied na pull natin para ma-stretch yung ating tape. We have due to slope, due to sag, due to normal tension. So let's discuss each of this in the following presentation. We have here a correction due to the incorrect length of the tape. So yung mismong tape is mayroong incorrect na graduation. So the absolute value of the correction per tape length is determined from the difference between your actual tape length and the nominal length of the tape. So the correction are determined using the difference between your actual and the nominal length of the tape. So to determine how are we going to apply the correction due to the incorrect length of the tape? So we have now, this is the general formula. We have the correction is equals to the correction, which is equals to TL minus NL times the measured length over the nominal length of the tape. So the CL, that is the correction to be applied on the measured length natin, we have the ml as the measured length plus minus because we don't know if it's positive or negative yung ating makukompute na C sub L. So, plus minus C sub L. So, where yung ating C sub L, that is the total correction to be applied to the measured length. Ito yung CL natin is the corrected length, yung na-correct na natin na length ng line to be measured or layout. Yung ML natin again, that is the measured length, and L is the nominal length of the tape. So, the second corrections na pwede natin i-apply sa tape is the temperature correction. Yung ating temperature correction, di ba mayroon tayong standard na during the manufacturing of the tape, meron lang itong standard na temperature na pwedeng gamitin. However, yung ating mga tape na gagamit natin usually medyo mainit. So, for example, 20 degrees Celsius lang yung kaya ng ating tape. And we use it on the 30 degrees or 35 degrees Celsius. So, nag-elongate yung ating tape because of the too much heat. And the same goes pag medyo lower ang temperature, nagsishrink yung ating tape. So, we need to correct the variation due to temperature. So, here's the formula to compute the correction due to temperature. We have your CT is equals to K times TA minus TS times the length. Ito yung length na ating yung measure. Where yung ating C sub T, that is the correction due to the variation in temperature. So, yung standard temperature lang usually goes around 20 degrees Celsius or 68 to 70 degrees Fahrenheit. The coefficient of thermal expansion ng steel, usually around this value. So, yung K natin, pag we measure the length in terms of in meters, we're going to use the 0.00116 per degree Celsius. However, pag in feet or in inches, gumagamit tayo ng 0.0000645 feet per degree Fahrenheit. Yung TA natin, that is the actual temperature. So, pa yung ating tape, ginagamit natin sa labas, and temperature sa field ay 34 degrees Celsius. So, yun yung ating TA. Ito yung ating actual temperature. Yung TS, that is the standard temperature. Ito yung temperature ng tape during manufacturing. So, paggagawa ng tape, meron lang siyang standard temperature, that is TS. L, that is the length of the tape used or yung total measured or layout natin na distance. So, here, how are we going to apply the correction due to the temperature variation? Pag ang ating na-compute na CT ay positive, then it means na tape natin is elongate. So, nagtulong sa. So, pag nagme-measure tayo, that the correction should be added. Pag nagle-layout tayo, that correction should be subtracted. Pag yung C sub T naman, it came out na negative ang value ni C sub T. So, the tape is shortened or cold yung temperature. So, that means the tape is too short. Pag nagme-measure tayo again, correction should be subtracted. Pag nagle-layout, yung correction is to be added. So, next we have the tension due to correction. So, during the calibration of our tape or yung pag-standard ng ating tape, so, subject siya sa certain amount of standard pull or tension on its end. So, pag ginagamit siya during sa field, so taping, so pwede siyang mag-elongate or pwede din siya mag-shorten accordingly. So, depending sa amount ng pull or depende sa amount ng force na i-apply natin para ma-stretch yung ating tape. So, if the pull is greater than that of which the standard or yung calibrated natin, pwede mag-elongate yung ating tape. However, naman, pag lesser yung ating pull ina-apply compared sa kanyang pag-standard or pag-calibrate, pwedeng mag-shorten yung ating tape. So, you have here the formula CP equals to PA minus PS times L over AE, where yung C sub P natin, that is the correction due to variation in tension or pull, is in meter or in feet. Yung PA natin is, ito yung actual, yung pull na i-exert natin during the measurement. You have the PS, that is the standard pull in kilogram or in pounds. Ito yung standard pull na naka-assign sa tape during calibration or during pag-standardize na. We have the L, that is the length of the tape to be used, or the total measured laid out distance. We have the cross-sectional area ng tape. Ito when we say cross-sectional area ng tape, pag yung tape, meron tayong tape, tas naputol siya, you can see on the end of the tape, yung naputol, that ito yung pinakamaliit na end ng tape, that is the area, kung ano yung area niya, yung naputol. You have the E naman, that is the modulus of elasticity ng tape. So, yung values na around 30 to 29 times 10 to the power of 6 pounds per square inch. So, ito yung value niya. So, to account for variation in the applied tension, a correction has to be applied or subtracted from the measured length natin. So, this correction for pull is a function of the difference between the applied pull and your standard pull, and the measured length and the cross-sectional area, also the modulus of elasticity of the material o yung tape natin. So, we have here, pag yung na-compute natin ni pull correction is positive, which means, again, the same kay temperature, nag-elongate yung ating tape. Pag ginagamit yung ating tape, pag me-measure, that is, correction should be added. The same lang kay temperature. And pag nagle-layout tayo, correction natin is to be subtracted. However, pag yung na-determine natin na value ng CP is negative, so which means the tape is too short or nagsusortin yung ating tape. So, pag ginagamit natin yung ating tape na nag-too short, pag measure, yung correction natin is subtracted. And pag nag-layout, yung correction natin is to be added. Next. So we have here we have the slope correction. So when the distance are measured along a slope or sloping ground, so the equivalent horizontal distance may be correspondingly be determined by applying the approximate or exact slope correction. So from the figure, we derive the formula in computing the slope correction as the following. We have here CH is equals to H squared, that is H squared over 2S, where in which your C sub H, that is the correction due to slope or the difference in elevation between the 2 points or imperfect alignment. We have the H, that is the difference in elevation between your point 1 and point 2 or point A and point B. Where the S, that is the measured slope or yung ating inclined distance. So you have here, that is only applicable for a regular slope. So, the concept of correction due to slope, we have here an illustration. We have the distance D. Ito yung ating corrected na line, yung D. So, from here to this point here. So, ito yung dapat yung corrected distance, which is the horizontal distance of your point A to point B. So, pag sloping, itong value ni S, that is the sloping distance of your A and B, is just equivalent sa ating here. So, this is the sloping distance. So, the correction due to slope, itong portion na to, this is the correction due to slope. So, to determine the value of D, meron given tayo kay slope. So, your D is just the difference of your S minus the correction due to slope. For the gentle slope, this formula is applicable lang kay gentle slope. We have here 20% slope, that is a gentle slope. So, C sub H equals to H squared over 2S, yung general formula. How about steep slope na? Between 20% to 30% yung ating slope. Kailangan natin gumamit ng itong formula. H squared over 2S plus H to the 4th power over 8S cubed. For a very steep slope, or greater than 30% yung kanyang inclination, so S equals to 1 minus cosine theta. So we are going to use the trigonometric function. So how are we going to apply correction due to slope? So take note, the correction due to slope is always negative. So because it always tends to make the measurement laid out, so distance longer than what it should have been, and there be no slope or imperfect alignment. So it should always be negative because pag slope, yung ating value ng S is always longer than the value of the horizontal distances. So again, the correction ni due to slope is always negative value. So when we say always negative, that is too short. So pag nagme-measure tayo, that is correction should be subtracted. And if we're laying out, correction are added. Okay, take note of the following. Yung ating correction due to slope is always negative. So, second is a sag. So, this type of correction, so a tape is standard length which is fully supported under the standard pull or tension. So, the pull is maintained but every support is removed such that the tape is only supported at its end. So, it will sag because of its own weight. So, it sags in its form of catenary just like the cable or for example in the illustration, yung tape longer yung another end. So, medyo distansya pa yung nag-hold ng other end ng tape. So, because of the weight of the tape, nagsasag yung ating measuring tape. So, hindi horizontal yung ating nakukuhang measurement. So, sag shortens the horizontal distances. Diba? Nasa-shorten niya yung ating horizontal distances between the graduations. So, it's always a negative value. So, your sag is always a negative values. It can be diminished by a greater tension. Pwede mawala yung sag pag stretch natin siya masyado, yung ating tape, nawawala yung ating sag. So, but not eliminated. Pero kung grabe yung ating tension na i-apply, so, hindi siya na-eliminate unless the tape is supported throughout its length. So, dapat support natin siya sa gitna para hindi siya magsasag. So, sag is the difference between the tape reading and the horizontal distance between your support and can be determined by the following calculations. So, the magnitude of the errors depends on the weight actually of the tape and the unsupported distance and the applied pull or tension. Kung gaano ba natin ka-stretch, gaano ba karaming support ang meron. So, kung mas maraming support, konti lang yung sag. Okay. So, this is the error due to sag. So, we can determine the error due to sag correction. How can we apply? So, CS equals to capital W squared L over 24P squared. So, yung C sub S natin is that is the correction due to sag. Ito yung i-apply natin sa measured length or measured tape natin. Your capital W, that is the total weight of the tape between unsupported distance. When say unsupported distance, yung walang nakalagay na support. Small w, we have here the unit weight of the tape per linear meter or linear feet. Ito yung weight ng tape na isang meter. 1 meter, ano yung weight ng tape in a 1 meter. CL, that is the length of unsupported distance. And your P, ito yung applied tension or applied force para maging straight ang ating tape. So how are we going to apply correction based on the due to sag? So always remember na ang ating C sub S or yung correction due to sag is always subtracted. So from the measured or layout distance because it tends to make the measured length naman distance or layout or measure this as longer than what it should have been. So we have here the formula. So yung if again yung CS natin is positive. So, this is always too long. So, pag nagme-measure tayo, it is subtracted. Pag nagle-layout tayo, subtracted pa din. So, pag nagsasag, always yung ating measurement is longer. That's why we need to subtract the correction. So, we have here the formula for a normal tension. So, this formula for normal tension is derived by the equation from the sag and the pull. So, combination siya ng ating sag and the pull. So, the equation by normal tension, this is also solved by the trial and error. So, masasolve lang siya using trial and error. Magsa-substitute tayo ng value kay PA, yung ating actual pull. So, kung yung ating i-substitute na actual pull ay magiging the same sa ating PN, so that would be the correction to be applied on your normal tension, where P sub n, that is your normal tension. Your W is just the same, that is the total weight of the tape. PA, actual pull. Your PS, that is the standard. Your A, cross-sectional area ng tape. E, that is the modulus of elasticity ng steel. We have here the, your normal tension is amount of the pull necessary to apply to a suspended span and tape in order to eliminate the correction for the effect of sag. So, ano yung tension na kailangan i-apply natin para mawala yung sag ng ang tape? Okay? So, if we're going to classify the different errors due to tape, yung ating tape length is due to instrument, diba? Yung instrument natin. We have for, that is an example of a systematic error. For the temperature, that is a natural, it caused on the environment. So, error due to temperature, that is a natural error. Pwede siya systematic, pwede siyang random, because yung tape na nagsishrink or nag-elongate, pag ginamit natin siya for many times, so nag-accumulate yung kanyang error. So next we have here, pull. So personal error because it depends kung anong klaseng pull o gaano kalaking force yung ating extend para ma-stretch yung tape. So systematic and random din siya. The sag correction is natural. So because natural naman na talaga na may weight yung ating tape, and personal because it depends on the tape man kung gaano siya nag-stretch or anong gaano kabigat yung tension na i-apply niya sa tape. Have the alignment, especially an alignment is that is a personal. So pag di naka-align yung tape, malaking error due to slope yung ma-accumulate, that is a systematic. Tape nut level is personal, plumbing personal, marking the tape is personal, interpolation is personal. So more or less, it depends on the surveyor, 'di ba? Personal, it depends on yours paano o kung anong klaseng methods ang gagawin mo, and the proper execution on how to use the tape. So it depends on the person who is holding the tape. Okay. So, another type of measurement. So, tapos na tayo sa taping, we have naman the EDM. So, ito yung electronic distance meter. Ito yung ginagamit natin ng mga instrument na with laser. So, ano ba yung EDM? So, electronic distance meter. So, hindi tayo gumagamit ng tape. So, this measurement of distance is based on the invariant speed of light or the electromagnetic waves in a vacuum. So, meron tayong dalawang classification. We have the electro-optical and the electromagnetic microwave. So, ito yung ginagamit ng mga total station. So, yung EDM, o kung ano yung, this is a electronic na to measure the distance, no need for a tape. So, the advantage na is speed and accuracy. Madali siyang gamitin. Lightweight and portable. Low power requirement. Easy to operate. So, ease in measurement over inaccessible terrain. Diba? Ang pag shorter lang na distance, pwede kang gumamit ng tape. How about 500 meter na yung distance or a kilometer? So, mas better kung you are going to use a electronic distance meter. So, applicable to measurement of both short and long length. So, this is automatically measures or displays and record the needed data. So, yung meron siyang maliit na monitor, they can directly give the value of the angle and a measurement in length. The slope measurements are internally reduced to horizontal and vertical components. So, i-eliminate na niya yung slope correction. Pwede siyang magdiretsyon paghataghin slope distance and the horizontal distance. This will be automatically accumulates and averages reading for slope reading range. So, naka-average na yung kanyang measurement. Pwede mo siya input into 10 times na siya mag-read, and the instrument will take the average reading of the measurement. So, again, nagbibigay siya ng horizontal and also a vertical, horizontal angles, vertical angles, horizontal distance, and slope distance. So, this is a total station. So, ito yung a combination siya ng transit and the EDM. So, meron siyang EDM ito sa ilalim. So, the angles and distance from the instruments to points to be surveyed are determined. So, ginagamit niyang concept ay trigonometry. Angles and distance may be used to calculate the actual points, either X, Y, and Z. So, three coordinate system ang nakukuha niya. We have the northing, easting, and the elevation of the surveyed points in absolute terms. Okay, so that will be the end of the chapter 2. So, next presentation, maybe I'm going to give you a sample problems with the solution. So, thank you. See you on chapter 3.